Hi, I'm glad to see you again. This is lesson 3 of fuzzy set qualitative comparative analysis. I'm Arch Woodside, a retired professor from Boston College, and this is a series of 15 to 20-minute lessons on how to use fsQCA. And it's about also asymmetric case outcome modeling, okay? We've been talking about what asymmetric versus symmetric means, and in lesson 4 we talk a little bit more about that. But today's lesson 3, we're going to get right to the use of the software, fuzzy set QCA software. And so let me share the screen here with you, and we're going to talk. Let's see. Lesson 3 is the basics in using the software, and hopefully we're going to do this in about 15 minutes here. So we're going to use Excel to record your data and fsQCA software to analyze your data. So in a minute, we're going to open the software, record your data, save your data, close the file, open fsQCA, open your data file in fsQCA, calibrate your data into 1.0 range, and then test your theoretical models, test abductive models, and I'll explain to you what that means when we get to there, and then test for robustness of your models. We may not get to that today, but we will get it to that in this voluntary course. So you're all volunteers in this course. Okay, so what you want to do is download the software program. So you can find this on google.com. Just type in fsQCA, and where it's mentioned software, click on that, and then download 4.1, fsQCA 4.1, or for Windows, or fsQCA 4.1 for Mac. So by clicking on one of those two, and you can also read about a brief explanation of the procedure. It's about 5 pages long, written by Charles Reagan, by clicking on the button right in the middle of this page, or right here. Okay, so I'm going to stop sharing on that and take you to the Excel file. You want to type your data in Excel and save it as a CSV file. And so we're going to do that. Let me go to and this is the data that we're going to be using. And so you might want to make a copy of this data and then use it in Excel. So I'm going to go to Excel, and let me see where Excel is down here. I may have to open up an Excel. No, here, I'll okay. So here's a blank Excel file. And so the first thing you want to type is case. And this is, and by the way, just use lowercase, because sometimes the program doesn't like uppercase. And then case, and then so the cases we have, we're going to have 6 cases Try it again. Case 1, 1, 2, 3, 4, 5, 6, and then price is our first. And at this point, it's a variable, so it's $1.98, $1.98, $2.98, $2.98, and this is what the cases are exposed to, and $3.98 and $3.98. And then the next variable is PAL, and what that refers to is who was shopping with the customer. Was someone, a friend or a relative, present with them? And so the first three cases, there's no one present, so that's a 0, 0, 0, and then we have 1, 1, 1. The last three no, we have a 1, 0, 1, no, or 0, and 1. So two persons had someone with them in shopping. And then the third one is expert, meaning that's the treatment that was given, or if there's no expert, it would be a 0. So the first person was an expert treatment that they received. The next person was 0, and then 1, yes, yes, 0, 0. I think I got that wrong here. Let me try it again. Got 1, 0, 1, 1, 0, 0. There we go. Then the last variable is the outcome, whether or not they purchased or not, purchased the product that was being promoted. Put on my other glasses here. And so we have the first person bought, the first case or person bought. Next one did not buy, and then the next two bought. Person 5 did not buy, person 6 bought. So look, that's the data file, and I'm going to go ahead and save it right now. Save it. It's always nice to save your data. And I'm going to let's see, hold on one second. I'm going to save it under Tenderfoots. There we go. Save. Okay, now what we want to do is to convert this, convert the data into calibrated scores, okay? So the first calibrated score is going to be for price. I'm going to put the word price and C at the end. C at the end. Now, the software program will actually do the calibration for us. So we can actually stop here, and I'm going to put this in center here, and then it's already saved. I'm going to press save again, and I'm going to stop here and use fsQCA to convert the data into calibrated scores. So it's actually a good idea to close your data here. Let's see. So I'm going to close the data because we've already saved it. and then I'm going to open up fsQCA here, and let's see, open up fsQCA down here. Okay, and then we have to pull up the file, open data, and it's going to be in Tenderfoot. And so we have to find Tenderfoot. And I don't see the data.
Go back again to Tenderfoot. Document.
Oh, I know why. I know why. Answer. We didn't save the data in terms of
CSV.
We have to go back to the data.
Save them as CSV.
Yeah, we have to save the data as CSV, and hold on until I open up the file. Yeah,
recent.
There's the data, and the
file save.
Yeah, okay, I got it. Save a copy, and then we want to save it as a CSV file. CSV, comma delete right here. We can save it like that, and we can call it. Let's give it a name. Let's call it retail experiment. Okay, and then save. Okay, now we can
confirm the save in Tenderfoot. Save as. Where is the location? This PC.
I'm sure it's there.
All right.
Why don't we save and look at it again? It's there. Okay, so let's try opening it again and see if we can pull it up. Open data, and do it like this, please. Tenderfoot. There's the data. We're going to open it. Okay, and we need to convert this into calibrated scores. So we look under variables, compute. We go to variables, compute, and we find calibrated scores. Okay, we click on calibrated scores and bring it up to the expression line. All right, this is the operation we need to do. So we need to plug in information about price. That's the variable we're going to be doing. So we bring up price in before the comma, and then we plug in the high price that's going to become 1.0, and we had $1.98. I'm sorry, the high price was $3.98. So let me go back and wipe that out, start over again. We go to calibration, which is what we're going to be doing now, calibration, and then we're going to be doing price. Then go on the other side of the comma, move to the other side of the first comma, plug in your high price, 3.98. Then go to the other side of the comma, your midpoint price, which was $2.98. Then go to the other side of the comma, plug in your low price, which was $1.98. All right, and the the condition we're doing is high price. So I'm going to call that high price. I'm going to call it price C and press OK. So there we got the information for price. And what it's given us is the 398 price. The calibrated score is 0.39. Now, if you want that to be closer to 1.0, you can just do it again and go below 398 to represent the full membership and high price. Remember, it's a membership score, and for low price. So, in other words, let's do it again, but compute and let's plug in calibrate up to the expression line, put in price again. And then put in, for example, $3.50, somewhat lower than the top price. Go to the other side of the comma and plug in the 298, because that's still your midpoint. And then go to the other side of the comma and plug in, instead of $1.50, plug in 225, 2.25, and then call this price CC, and then press OK. And there we have the 398 price being calibrated to 1.0, and the $2 and then $1.98 price calibrated at 0.02. All right, meaning a very, very low score. And the 0.95 and the 0.05 is to indicate the range of anything above 0.95 would be high, anything below 0.05 would be low. So let's save this, just press save, and let's go on to the next. Actually, if you look at the data, you can see we don't need to calibrate anything else because PAL, expertise, and purchase is already in the range of 1.0. So we got our calibration done. So look, now we can actually, and this is really the neat part, we can actually look at the individual conditions affecting purchase. So we can go to graph. If you look at graph and click on fuzzy and click on XY plot, the x-axis and the y-axis is your outcome condition, and here it's purchase, and then an income condition could would either be price or PAL or expertise. Let's click on price, and now before we do that, let me say this: we want to test the simple model of low price predicts high purchase or purchase. So we have to look at the negation of price. So we actually compute the negation of price. Is you go into variables, compute, and go down to not X under your functions, get rid of this, and bring up not X in the expression line. And we're doing this for price CC, for example. And so this would be not price CC, and click on OK. So this gives us now that the low price is 0.99. So this condition represents the negativity of calibrated price, and the highest price is now 0. So let's graph that. Fuzzy set graph XY plot, where we're doing purchase by the negation of price. And then you click on push case in your case ID. So that'll give us the case number for each location of a case in the XY plot. And so now we can plot. And what we see here is that we got 6 cases. We got 5 dots because 2 of the cases are located in the same position. If you click on a dot, you can read at the bottom how many cases are there. There's 2 cases, and one of the cases is well, there's 1 case, but the name of the case is 2. That's the identity we gave. We simply gave a number from 1 to 6 to represent the cases. This case up here is case 1, and there's only 1 case there. Case 3, there's 2 cases there. Case 3 and 4 were found to be at the midpoint in this algorithm, which is a simple, not then low price, and it's the midpoint on the price scale. All right, so and then we have one case there, case 6, and 1 case here. So all we are predicting is that if you're high on the negation of price, you're going to be high on purchase. And the model does not work that well because we have 1 case that scores high on Y and 1 case that scores low on Y among the 2 cases that score high on the negation of price. So if we change this and do a graph of PAL, you might expect that high PAL would be negation of purchase. I mean, high PAL would reduce purchases, or it could increase purchases. You can make a case either way. But if you look at the plot, let's just look at the plot once for PAL and do a plot on that, and we see that the plot indicates that we have among the cases that are high in PAL present, we have case 4 and case 5. I'm sorry, is that case 5? Yeah, or case 6. Sorry, case 6. Yeah. So both cases purchased here. And so the model works quite well. Among the 6 cases, 2 cases have a high or high in PAL. The PAL is present, and both cases bought. And so this value up here in the left-hand corner, the 1.0, represents the accuracy of the case. So the case is completely accurate in predicting high purchase if you're high in X. And let's see, we had 2 cases that was not PAL and did not buy. So the number up on top is an index for consistency. It's like it's analogous to a correlation coefficient in regression analysis. Now, and so this number in the top left in the consistency index is a very important finding in your research because you want the consistency index to be fairly high, meaning that among the cases that are high in your X condition, whatever it is, simple or complex, almost all of them are high in Y. All right, it's if you're target practicing with a bow and arrow, it's similar to the answer the question, out of 10 arrows, how many arrows hit the bullseye? And here we only have among the attempts to hit the bullseye. So, and the number down on the bottom right, which is 0.50, indicates the coverage of the model among the cases that are high in Y. So there was two cases high in Y, and of the two, one was high in X. So that's looking at it of what Y indicating X. And so the model indicates one of the two cases that are high in Y. So that's called the coverage index. And I'll show you the computations of those within the course as well. All right, so what I'm suggesting to you right now is that we look at a fuzzy statement, and this is where the name comes from, fsQCA. If we build a model, and that's what we can do right now, we can compute a model, which is kind of neat. So let's look at a model of low price and a PAL present. Okay, so I'm going to get rid of this. I'll delete, and I'm going to go to fuzzy and statement. So this is building a model of, I'm going to get rid of that, so I'll put it back in a second. The two conditions are PAL present and comma and negative price. And I'm going to suggest to you that that model is going to work very well. And let's just call that what it is, PAL, and then negative price, which means low price. Okay, and then say okay. And notice there you go. There's the model where you have PAL present and low price, and so and this indicates that we had nobody where the PAL was present and a low price, but we had one person that had PAL present and a moderate price. So if we would graph that as the antecedent condition, here you have a situation where the model is highly accurate, 1.0 for consistency, and but nobody scored above 0.50. So the model works, but it does not provide extremely high accuracy in the outcome condition. So let's stop with this analysis and go back to the PowerPoint here, and this model here, this is price and no PAL. See, we just looked at price and PAL. It turns out that with no PAL present, we had one person that with no PAL present that actually bought with the low price and no PAL. And this is expert. I'll tell you what, let's look at low price and expert, and we'll end up seeing that I think I need to looking at the data. Let's put that in terms of a computed model. If we go into variables and compute and look at the fuzzy and statement, let's do that. Fuzzy and statement for low price. So that's the name of that is no price, and then comma, and an expert condition. So this would be expert and no price. So we're creating another condition here, and this is a complex condition, and there it is. So we have a situation where we have one person that is in this complex statement that scores high in this model. And let's graph this model. All right, so this is a XY plot where we're looking at expert and no price. And here, this is what we end up with. The model works extremely well. And we got four dots and six cases. One of the dots has more than one case in it. Like the bottom left dot has two cases in it, and the coverage is the consistency is 1.0, and the coverage is about 0.50. The numbers look a little less than 0.50 here because of the coding that we used, the calibration codes that we used. And nobody who scored high in this model, which is expert and no price, and in other words, expert and low price, that they saw, no one scored high, scored low in purchase. Nobody bought. They all bought, but there's only one person because we only had 6 cases here. So this whole region of the XY plot is zero. It has 0 cases in it. And this is what we'd like to see an asymmetric model. That high X indicates cases that are high Y. That's the end of the story. That's the full story of model building that we would like to see. And in real life, if you have 200 cases or 1,000 cases, you're not going to get this level of accuracy. But and we'll do a problem with more cases in a future lesson in this course. All right, so I'm going to go back to fsQCA here, to the PowerPoint slides, and mention to you that the takeaways from this brief lesson here is that you can propose specific complex antecedent models, and a complex antecedent model would have 2 or more conditions conjoined together, such as PAL and low price, or PAL and high price, or expertise in PAL. You can look at that. You can also look at it from instead of writing your own fuzzy statements, the software will write fuzzy statements for you of what actually works in your data. And I don't want to hold you beyond 15 minutes, so I'm going to show you this in a future lesson of having the software test the models for you instead of you writing out the model and testing it by looking at the XY plot. The software will actually do it for you and come up with the models that work. It's similar to stepwise regression model, but I'm saying to you now is that you should have an idea of what models will work in your data to give you your high scores in the cases with high scores in your outcome condition. So include XY plots when reporting your findings. And if you have questions on this, contact me. Now, we're going to need another lesson to look at how the subroutine software will actually create the complex statements that work, okay? And we're going to do that. We'll do that in the very next lesson, all right? So thanks for being here today. And I'm going to suggest that you come again because we've only touched part of the procedures of what you need to do to use the software. So do come back for lesson 4. Okay, so let me sign off for now. Thank you.